Wednesday. Okay, so we have here probability distribution. So this is the last unit here. There are going to be quite a lot of formulas that you have to memorize. Again, just as a heads up, any formulas that we have done, you have to know for your exam. There is no formula sheet for your exam. The only thing you will be getting is the Z score. So please keep that in mind. So a probability distribution is a table or a graph or an equation that illustrates the probabilities of all of the outcomes, not just a specific outcome, but everything. So a discrete random variable is a variable x that represents all of the outcomes of an event. So we're going to look at some examples here. I have here, we're going to look at some common ones. Natalie, you okay? The first one is rolling a single die. The outcomes, how many outcomes do I get when I roll a single die? Six. I can get an outcome of 1, 2, 3, 4, 5, and 6. Billy, what's the probability of rolling a 1? Pat, what's the probability of rolling a 2? Natalie, 3? 1 out of 6. All of these have a probability of 1 out of 6 when you're rolling them. Okay, so just as a sketch here, because we're going to be, we're now combining this unit. Natalie. We're now going to be combining this unit with our second unit of normal distribution. So again, if I were to graph this, I'm going to sketch it here. X represents all of the outcomes. So here you would have, again, 1, 2, 3, 4, 5, 6. And then on your y-axis, you would have the probability of that outcome. The probability here is all 1/6. So I'm just going to do here, we'll say that that value there represents 1/6. And I would have here, this is a uniform distribution. The probability that you will roll a 1 through a 6 is all uniform distribution. The dice isn't loaded. Each of those has an equal probability of that event occurring. Mike, what are the outcomes here when I flip a single coin? Yep. I can flip a head or I can flip a tails. Michaela, what is the probability of me getting a head? And tails? Good. Now, something you will notice here, which is important, if you were to add up all of these 1/6, Powell, what would you get? If you were to add 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6, what do you get? Pardon? Not 1/36. Mitchell, can you help him out? You get just 1, which is saying you have 100%. There's a 100% chance that you will roll a 1 through 6. Same thing here. When you flip a coin, if I add up these probabilities, 1/2 plus 1/2, there is a 100% chance that you will have a head or a tails. Does that make sense? It's kind of like that basic logic that you're like, okay, obviously, do I really have to state it? We're going to be looking at that. Okay, so that was, again, if I were to sketch out what this graph would look like, again, X down here represents all of the outcomes, which are heads and tails. My y-axis here will represent the probability of that. And here again, I'll have two options. One is heads, one is tails, and both of those are 1/2. Again, this would be a uniform distribution. Are we okay with this right now? I haven't done any rocket science. This is basic kind of probability. Okay, we're now going to look at one other case, and that is rolling 2 dice and getting the sum of the dice. So one of my outcomes here is 2. My outcome is 2. Spencer, what's the probability of me getting a sum of 2? Very good, 1/36. Scott, what's my next outcome? And what's my probability of getting a 3? 2/36. Curtis, what's my next outcome? And what's my probability for that? Okay, we'll keep it all in 36s. So 3/36. David, what's my next outcome? And what's my probability of getting a 5? Good. Joanna, what's my next outcome? And what's good? Johnny, my next one? Okay, I have. Do you see a pattern going on in the outcomes? So what do you think would come next? What's the probability of me rolling a 7? If I were to count up these 7s, these are all of the ways I can roll it. There are 6 times I can roll that. Noah, what comes next here? And what's the probability of that? Can you double check that for me? Five out of 36. What comes next, Billy? And next, Pat? Out of 36. Natalie, the next one? What's my outcome? And what's the probability of that? Thank you, Pat. I hope you guys are paying attention to this, because if not, I really don't know why you're here, to be honest. Mike? And there's a probability of? Okay, so I have all of these probabilities down here. Now you'll notice that when I'm rolling 2 die, it's not the same probability. If I look here, you know how you see, like, lucky number 7, you've heard of that. I think they even made a movie called Lucky Number 7, even though it had nothing to do with probability. The reason why they've considered it to be lucky is because that occurs the most. You can roll 7 the most amount of times with 2 die than any other number. And when you actually figure out the probability of that, it's only a 16.67% chance that you'll actually roll a 7. Is it that lucky? I don't know. That's up to you to determine. But that's where the lucky number 7 comes along, because that's the most amount of ways you can do this. So now, what I have here, if I were to sketch this out, this is going to look something different. You could probably tell. I'm going to put here, I'll say like this is 1/36, 2, 3, 4, 5, 6 out of 36. I'm just not going to write the denominators because it's going to look a little bit sloppy. And these are my P of X. So again, all of this is over 36. And for my outcomes, I have, and I have here, we'll have 2, 3, 4, 5, 6, 7, I'm going to run out of room, 8, 9, 10, 11, 12. Okay, it's a really big sketch of this graph. And what you'll find when you sketch this graph here, I'm going to do a histogram. When I have 2, so I had a 1 out of 36. My 3, I had a 2 out of 36. This is really bad. Because they're all, just remember, they're all supposed to be even lengths. Then the next one's 3 out of 36, 4 out of 36, 5 out of 36, and then I have 6 out of 36. It'll look something like this. How would we describe this graph here? Mike, do you remember? Anyone remember? Thank you, Joanna. This is a normal distribution graph. Okay, so we're going to be talking about expected sum. So this question down here says, what is the expected sum when rolling 2 die? How do you know? Even though the probability is not the highest, like it's only 16%, we would expect, and playing this game based on the probability, the expected sum we would get is 7. And that is because it has the highest probability. Now, you also have to know that the 7, because it's normal distribution, that 7 is the mean, median, and mode when we're talking about all of the outcomes and the probability. Does anyone have any questions with what we've done so far? Okay, here comes your first formula that you will have to know. Finding the probability that the sum is 5. So again, we're setting this up. The probability in brackets, the sum equals 5, is a specific probability. Finding the probabilities of all the possible outcomes to a die question is a probability distribution because it involves looking at all of the outcomes. X, large X, is the criteria or the condition that we want to meet, while little x is the number of times we want to meet it. So the expected value is the predicted average of all possible outcomes, the average of the discrete random variable, the outcome you are most likely to expect. So your expected value formula is this. Right here, and you have to know and memorize that. So it says here the expected value is the sum of the value of the outcome times the probability of that outcome. So the value of the outcome, for example, here would be 2, 3, 4, 5, 6, 7, 8, 9, 10. The probability of that outcome is here. And all we're doing is we're multiplying the two and then adding them together for what we want. So I have here, what is the expected value for the sum of 2 die? So the expected value, again, I'm going to write it like this, is the sum. This is the sum. That means sum, which means we have that. Have you guys seen that notation before? Have any of you seen that before? Okay, that just means we add up all the possible cases together. So I'm going to add up here. This is saying the sum when I equals 2, so this is your lower bound. That is the smallest value that you can get on your when you roll die. And then up at the top here is 12. So it's saying I'm going to add all of the numbers from 2 to 12 with that probability. And then I have in general notation here xi times the probability when x is equal to xi. Okay, so this is very generic, and I'll show you what this means. So again, xi is the outcome, the value of the outcome. So if I'm doing this, I'm going to start with my lowest bound. My lowest is 2. I can roll a 2 when I roll a die. That's my smallest value. What was the probability of me rolling a 2? 1 over 36. Okay, so I'm just looking at this chart up here. 2 times 1 over 36. I'm going to then add it with, what would be the next number that I can expect in this? Michaela, can you help me out? Very good. 3 times 2 over 36. Ben, did you get a late flip? Okay. What would be my next one that I have to write down here, Powell? Very good. Mitchell, the next one? Plus 5 times 4 over 36. Very good. Okay. Do you get kind of, well, we'll write the whole thing out. Plus what, Spencer? Good. Plus what, Scott? Good. Plus what, Curtis? Good. Plus what, David? Tuck in your shirt. Joanna, the next one? Very good. Plus what, Johnny? Very good. Plus what, Noah? Okay, that's what that's talking about. The summation sign here means we add up each piece. So right here, that is one piece. That is this once. And then I add it with the next value, which is 3, then the next one, then the next one. So that's what the summation means, is I add all of those pieces together. Okay, so to find the expected value here, what you would do is you would type this into your calculator, the whole thing. So you actually end up getting, you can take my word for it instead of doing this calculation right now, but you will have to do it. If you're not sure how to work your fraction button, then you make sure you let me know. But you will get 252 over 36. And the note's in the folder if you want to go get it. Which is equal to what? Our expected value is 7 when we roll a die. So again, that was using that formula. We, already knew what that was based on the normal distribution graph. This is a fairly common example that you will that you will see. But this just shows you how this formula for the expected value works. Does anyone have any questions about this right now? Okay, what is the expected number of heads if you flip a coin 3 times? Okay, so in order for me to do this, I'm going to draw a tree diagram to demonstrate what can happen because I need that information. So on my first flip, I can have a head or a tails. On my second flip, again, I can flip a head or a tail. On my third flip, again, heads or tails, heads or tails, heads or tails, heads or tails. Billy, if you follow the top branch, what are the options there? Yep. That's 3 heads at the top. Pat, what comes next? Heads, heads, tails. What comes next, Natalie? Good. And what comes next, Mike? Very good. And what comes next, Michaela? Very good. And what comes next, Powell? Oh, I did that backwards. Okay, Mitchell, what comes next? Good. And Spencer? Good. Okay, so these are all of the possible outcomes that I can have here. Now I'm going to analyze this because I want to know what is the expected number of heads if you flip a coin 3 times. Well, if I have 0 heads, how many ways can I get 0 heads, Scott? Out of? There is a 1 out of 8 ways that I can roll 0 or that I can flip 0 heads. 1 head. Curtis, what would it be? How many ways can I roll or flip 1 head? 3. 3 out of 8. And how about 2 heads, David? Good. And Joanna, how many ways can I roll 3 heads or flip 3 heads? 1 out of 8. Anyone have any questions about how I've gotten these? So I now have the outcomes. The outcomes here, so I'm talking about flipping a coin 3 times. My outcomes here are 0, 1, 2, 3 heads. The probability is 1/8, 3/8, 3/8, 1/8. So for me to find the expected value of when you flip a coin 3 times, it becomes the expected value of heads is equal to, Johnny, what would I write for the first one? What is the first possible outcome that I can have? Okay, Johnny, so what's the first one? 0 times 1/8. So again, you can roll 0 heads and multiply it by the probability, 1 over 8. I'm going to then add it with, Noah, what would be my next outcome? Very good. 1 times 3 over 8. Plus what, Billy? 2 times 3 over 8 plus what, Pat? Good. 3 times 1 over 8. Okay, I'm going to give you a moment. I want you to, well, yeah, I want you to put this into your calculator and tell me what you would get. Natalie, what do you get for your final answer here? Which is, as a decimal, how many heads could we expect to flip? 1.5. So again, you can kind of 1.5, that's how many times we would expect. Even though the 0.5, we can't flip half of a head, but that would be the expected value for that. Okay, the next example here. It says, Natalie, you know that it's kind of rude when I'm trying to teach and you're talking for the majority of the lesson, right? Okay, sorry, Natalie. Just if you have a question, please ask me. So I don't think someone's rudely interrupting me, okay? So it says, example 3, a prize table has, or have, 3 prizes worth $50, 2 prizes worth $25, and 5 prizes worth $10. What is the expected value of the prize that is selected? Okay, so in order for me to do this, I have to figure out, well, how many prizes are there, which is saying my denominator, my NS. I have 3 prizes of 50, 2 of 25, 5 of 10. So I'm going to write here 3 plus 2 plus 5, which gives me, there are 10 prizes up there. I'm going to draw a little chart here to help us out. Remember, X is the outcome. The probability of X we'll figure out. So one of the outcomes of selecting this prize would be what? Mike, can you help me out? Doesn't matter. You pick a prize. Which is what? What prize are you talking about? Okay, so the outcome, we could have a $50 prize. How many $50 prizes are there, Mike? There's 3. So what's the probability of selecting a $50 prize? Very good. Michaela, what's my next prize? Good. And what's the probability of me selecting $25? Very good. And Powell, what's my last prize? And the probability of getting that? Very good. Does anyone have any questions about how I just came up with this? You will notice that when you are doing all of these probability distribution questions, P of X, when you add up P of X, it has to give you 1, or in other words, 100%. We're accounting for all possible outcomes here. So the expected value, so the expected, and then I'm going to say, yeah, the expected value is equal to, what would be my first case here, Mitchell? Good. What would be my next one, Spencer? And my last one, Scott? Very good. Curtis, when you add and multiply all of that up, what do you get? You get 25. So you would get 250 over 10, which is equal to 25. So the expected value of the prize that you get from this table would be $25. Okay, the next example here. A game consists of tossing 2 coins. If the result is 2 heads, you win $1. If the result is a head and a tail, then you win 50 cents. And if the result is 2 tails, then you lose $2. What is the expected value of the game here? Okay, so I'm going to go here. Again, I have X, all my outcomes, over the probability of that actually happening. So I'm going to look at my first example here. So it says if the result is 2 heads, you win $1. So my outcome is $1. I would win, and I get that by flipping 2 heads. David, what's the probability of me flipping 2 heads? Yeah, so that's like saying 1/2, because I have a 50% chance for my first head, times 50% chance for my next head is 1/4. So my next outcome here, if the result is a head and a tail, then you win 50 cents. What is the probability of me flipping a head and a tail? Joanna? Very good. 1/4. Now there's another version of this, because I also have to take into account when you're flipping 2 coins, or if you flip you toss 2 coins. I could also have a tail and a head. And again, that's the same thing. I would win 50 cents. Ben, what's the probability of me flipping a tail and then a head? Good. And then I have here, I lose $2 if I flip 2 tails. So that would be like a -2 if I flip 2 tails. What's the probability, Johnny, of me flipping 2 tails? So if you're playing this game, what would you expect? I want you to set this up right now. It's exactly like we've done before, and then we'll... Okay, Noah, what did you write down here? Tucking your shirt. I'm sorry. I'm holding it hostage until you come up and you tuck in your shirt. Okay, Noah, what do I write for the first one? Okay, so tell me what you do for the first one. Very good. 1 times 1/4. Billy, what comes next here? Good. 0.5 times 1/4 plus what, Pat? Good. Plus what, Natalie? Good. So I don't actually have to write a plus. I would write -2 times 1/4. Mike, when you put all of that in your calculator, what did you get? 0. So you are expected to win $0 in this game if you play. Okay, so this question here, is the game fair? If I told you it costs you 25 cents to play the game, why or why not? Would you say that this game is fair? Base probability. No. So no, you pay to play, but are expected to win nothing. So it's kind of like buying lottery tickets or playing games at the casino. Your expected value, you're not going to win. Those games are not fair. You are not walking out with the amount of money. You're paying to play, and there's no guarantee you're going to walk away with anything. That's the expected value. They make these games, the government does, so they can make money, not lose money. Okay, our last example for the day. So it says, if we randomly select 4 students from our class to help with grade 8 day, what is the expected number of girls on the committee? Well, this is, okay, so how many girls do we have in this class? 1, 2, 3. So our class right now, we're supposed to have 18 students. And out of the 18 students, we have, right, we only have 3 girls. 1, 2, 3. We have 3 girls and 15 boys. I don't know if you've noticed this at Holy Cross, but the guy population, the male population, is much higher than the female population at this school. So if you look, the majority of your classes, there will be fewer girls and more guys in all of them. And depending on most classes, like all of my classes, I have, again, 16 guys in my grade 10 class, 2 girls. And then it's almost divided that way for it. So it's just interesting. I don't know if it's the water around this area that you're guaranteed a guy. I don't know. But that's just the dynamics of our school. Okay, so we have 3 girls, 15 boys. So right now, I'm going to figure out my denominator. So I'm choosing. This math never goes away. I want to pick 4 students. So I'm going to have here 18, choose 4 students. What do I get when I do 18, choose 4? Michaela, can you help me out? $3,060. So that's how many ways I can possibly choose 4 students in this class. Okay, now I have 3 girls here. What is the expected number of girls on the committee? So if I'm talking about here, I'm going to make my chart. I'm going to do it a little different. I'm going to have X. Then I'm going to have the numerator here, and X. And then I'll have the probability of that actually happening. Okay, so if I have 0 girls, that is one possible option here. Powell, how many ways can I choose 0 girls? What would I write? Very good. And that gives me a value of what? So Mitchell, what would be the probability of choosing 0 girls? We'll rate it as a fraction, which very good. And what do I get for a decimal there? We'll round to 4 decimal places. Very good. 0.4461. Spencer, I want to pick one girl. What's the probability here? Or what would I write here? How many ways can I choose one girl? Very good. And that gives me what, Spence? Okay, so what would be the probability for that, Scott? Very good. Okay, for two girls, what would be the probability for that, Curtis? Which gives me what? Very good. So David, what would I write for the probability? Good. And what is that to 4 decimal places? Good. Okay. And to have 3 girls. Joanna, what would I write here? How many ways can I choose 3 girls? To 4 decimal places? Thank you. 0049. Okay, now one thing you will notice here, again, when we're talking about the probabilities, because we've set it up this way, if you were to add all of these probabilities in this column here, you will get 1 because we are counting for 100% of the ways, or really close because we are rounding, so there is a little bit of room for error. But if you were to add up all of these fractions, 1,365 plus 1,365 plus 315 plus 15, you will get that you have 3,060 over 3,060, which accounts for all of the probability. So all of these added will be equal to 1. Okay, so now I want to find the expected number of girls in this class if we were to do this. So my expected value here is, what would I write for the first piece? Ben, can you help me out? What's my first outcome that I have there? My first px, or sorry, yeah, my first x. Very good. Okay, I'm going to add that with the next one, Johnny, which is what? Hello? Yeah, I'll send her after the lesson. Okay, bye. Join after the lesson. Mrs. Thompson wants to see you. Okay, Noah, what's my next one? Good. Plus what? Billy? Very good. So Pat, when you put that into your calculator, your expected number of girls in this class, if I'm picking 4, is what? Pardon? I'll wait. Johnny, go get that right now. Okay, so our expected number of girls is not even one full girl, 0.6. Okay, I'm going to be giving you a worksheet where you can practice this.